Hello everyone, welcome back to this Building Up Your Own PLC and HMI SCADA System series video. In this video, I would like to discuss the TwinCAT measurement function YT scope. YT means the x-axis, that's the time, y-axis, that's the value. This is a very common function when we need to record some value, or especially when we try to use the oscilloscope function to record the signals when doing the signal analysis. So the YT scope function is very useful. Or some cases, if you are going to do the function, that means X is your input, Y is your output, so you can use XY scope. But in this video, I will discuss this common function. Most of the features of them, they are quite similar, so I will use YT, this common function, as an example. Regarding the scope, trend, or curve function, this TwinCAT measurement scope tool, this is a really great tool compared with other brands. Another good trace function that comes from Siemens TI Portal. A good feature of the trace function in TI Portal, that is sample time. The sample time could be the same as the cycle time of the PLC, so that could be very fast. However, it's limited to length because the trace function stored all the data in the PLC in the hardware internally. Because of this, store the long-term data won't be available using the trace function in the TI portal. Basically, this trace function will be used for troubleshooting, for recording the data just within 1 minute, usually for troubleshooting the signals or the timing chart. For example, if you have the sensor has a flickering signal, this trace function can very clear to see the issues. This is the Siemens TI portal. Compare another one that is the Allen Bradley, RS Logix 5000 or Studio 5000. Frankly speaking, that trace function is so pro. Basically, to analyze everything, you have to export the data into Excel and then do the analysis again. It's hard to use to zoom out or zoom in or do the further analysis in that trace function. Back to the TwinCAT measurement function, because we are using the laptop computer to run this software. So all the record data will be stored into the laptop, the computer. So you could have tons of room to record all the data here. Another great feature of this TwinCAT measurement function, that is the standalone project. I pretty like this feature, especially for the researchers. If you are going to use one laptop, especially to record all other data from the PLC, so you can create one standalone measurement function. It do not need to attach with any other PLC project, so it can run as a data recording center, and especially for monitor all the trend from different PLCs. And it has OPC UE communication, so even you do not have a TwinCAT PLC, Beckhoff TwinCAT PLC, you just use this software running as a data center to record all other OPC UE servers data. More importantly, for the short-term recording, as an engineering purpose, if you record the data just for minutes or within 1 hour roughly, that's for free using this software. You do not need any license. If you do need a record for long-term run, for example, you need to record months or years to record for a long-term trend or curve, so you need to purchase a license that named the TwinCAT measurement server. But most of cases on site, when we're doing the engineering program or troubleshooting, this TwinCAT measurement, that's fully enough. This is for free, and you can create the project standalone. So it's very convenient. All right, let's start. In this video, I will introduce some typical feature from this YT scope. And I won't go through every features of them, but I will introduce most of the features I like and most of the features I usually use. Okay, let's go. Let's quickly review my program. So in this test program, in this variable list, my global variable list is named V variable. And here I have a couple real these variables. And in the program, I have two sign calculation here. One is very simple. So this x1, v.x1 is doing 0 to 360. It's cycling from 0 to 360 degrees. And from here, it's translated to radius. And from here, I calculate to YA sign. And this YB sign, I'm using a little bit complex. I have a 2 sign calculation. Their frequency are not the same, and their amplitude is not the same as this one. So eventually we will monitor this X1 and 2 sign result, YA and YB sign. Okay, this is the PLC side. This is the typical way when we need to use the trend or scope to troubleshoot our variables to verify if something wrong or if some signals just happen in couple milliseconds, that short period. Okay, let's go to set up one project. So you can create one totally standalone project. Okay, from here, this is my current project. From here, I can add one new project. Okay, new project. And I can search, go to the TwinCAT management. Okay, and from here, let's select the YT scope project. YT means this is the time, is the x-axis, y is the value. Okay, this is the typical function we will use. Okay, and this is the folder. Check out the folder you are going to locate this project. So I can call this project, just name the TwinCAT management project. Click OK. So you can see they are parallel. So this management project, this is totally standalone. Okay, from here, let me quickly explain. So the data pool, this is the place to allow us to connect or browse the PLC variables and drag the PLC variables to this data pool. And the variable under this data pool belongs to this measurement system. Okay, and the YT chart. YT chart, that means this is the YT chart here, YT chart. That means we open one sheet. In this sheet, we could have a couple group or axis. Here, the axis group, that means this is the axis here. If I create another axis here, for example, new axis, we can create 2 axes. But the y-axis, we could have a multiple y-axis. This is very flexible. For example, if you are recording one motor output or one servo motor output, you have a speed, current, torque, and precision. So you could have 4 different axes: current, speed, torque, and the precision. But the time is the same, right? So you like to analyze at that short period when the current going high, suppose the torque should go high, and which position that high torque happens. So you can diagnose if there's a gearbox or something wrong that short period. So this is very convenient. And using the trigger function, you do not need to recording always. So you can use one single to start the recording function. Okay, this is a quick global view. And then let's go to the data pool. Okay, before we start the data pool, we need to guarantee your PLC is running and all those variables or your target variables has been running into your PLC, the TwinCAT PLC. Now I'm going to use my laptop, this computer running this program. So here I select the local, okay? And I will download this PLC program to my local. So I will use my laptop running as a PLC and run those programs. Click this active configurator, and here it mentioned me I have a license need to reactive. Okay, for the learning purpose, every 7 days we will reactive the license. Okay, here I will type in this. This is very convenient. Okay, reactive. So the license we just reactive at here. If we go here, license, that means okay, I just active the PLC license. If I shift over, so we'll see. Here got a refreshed. Okay, this is the PLC license. Now we download this hardware configuration and then let's click this login. So we will download the PLC program. Okay, once we see the icon shows like this green plate got green, and here it shows the green has a yellow gearbox running inside, so it means the program we download and we are online. So we can see this variable changing from 0 to 360 degrees, and it's calculating 2 different results at here. Okay, we will monitor these 3 variables, X1, YA, and YB. And then now this PLC is running. And then let's go to the data pool. So data pool here, let's click this target browser. Okay, from here, this is one of the beauty feature from this TwinCAT management. If we are going to record or online monitor the local PLC or other TwinCAT PLC, we can click the ADS. You can browse or you can add. You can browse one remote TwinCAT PLC running somewhere in your network. Okay, this is the ADS. ADS, this is the protocol of the TwinCAT. So in my local, it browses my local PLC, and from here, under the V variable list, I have a couple variables. If I go here, you can see they are the same. It browsed already. Okay, this is my local TwinCAT PLC. Okay, port 851. That's the port number come from here. Because in one project, you could have a multiple PLC project under this project. So my default PLC port, that's a 851. So it searched this 851. Okay. And another beauty feature you can see here, OPC UE. That means even you are not using TwinCAT PLC. For example, you are using Siemens PLC or Omron PLC, Sysmax Studio. So that PLC basically all support OPC UE from the controller. So you can activate that PLC controller as OPC UE server. So from here, you can browse the OPC UE server, browse that OPC UE controller. It crosses the brand and across the platform. It's very convenient. Okay, now let me drag the three variables we are going to monitor. I will monitor the X1 and YA, YB. Okay, so we drag these three variables to the state pool. That means we told this measurement system, okay, you have three variables. These three variables come from the PLC, come from this target port, come from this PLC, and this variable is named. And this variable in the PLC is named v.x1. Keep in mind here, the name at here and name at here, we better name them is the same. Okay, otherwise some cases you can rename this variable at here. For example, I can rename to just add a XX. So we can see the name at here that's only used in the measurement system. However, some cases you may forget where this variable actually come from, right? That came from, this is the PLC actual variable name. Personally, I would recommend you name this variable as the same, because some cases, if you watch out this variable showing in the trend, you found something wrong, then you want to go back to the PLC program, do the troubleshooting. That time, if this name, they are not the same, it's really hard to trace down. Keep in mind, this name here, this is the PLC variable name, and this is the PLC target. Okay? Okay, other than the name, one thing you also need to take care is the sample time. So, as we can see here, the sample time is select this task sample time. Okay? This task sample time, that's the 10 milliseconds. And this task sample time come from my PLC project, and my PLC project here, this task, PLC task, this is the 10 milliseconds. Okay, basically they match. It doesn't matter as long as this time not slower than the PLC time. That will be fine, because if your sample time is slower, sometimes you will miss some variables, you'll miss some signals, right? Or if you need to manually set a faster sample time, then you can select the free sample time. You can reduce this sample time, okay? But keep in mind, the smaller sample time of here, the bigger data you will store behind, right? So keep in mind, you need to trade off something here. Basically, we will select this task sample time. This is the same as your PLC project. Okay, this is the variables we can go through. YA sign that came from the YA sign V dot. So if I open here, we will see we drag these three variables from the PLC to here. Okay, so this is a variable and a sample time setting. Then let's go one hierarchy above. Here, this is a very important setting from this global view of this scope project. I highly recommend you can select the couple settings as below. So first one, this is the auto save path. We can see default, it will save the recording files under your project folder. Sometimes you need to record a lot of data behind. Probably you can assign one directory, that directory into your local computer. you need to specially record all the data into one specific folder. Then from here, you can assign one specific directory to store all those recording data. Okay? Okay, after we set this recording path, then there are a couple settings I highly recommend. So for this area, so basically rain buffer we set to 2 and restart also set to 2. And this file store, let's select to true. So we store the data. And this record time, you can set a certain long or certain short. That depends on which job you are doing. For example, if you are doing the troubleshooting, maybe 1 minute, 60 seconds, that's enough. If you are recording a long term, probably you can set a couple minutes or even 30 minutes, right? So usually I will use this measurement system for the troubleshooting. So I will set 60 seconds. Okay, this is the 1 minute. Okay, basically I will select those settings to here and this recording time. Okay, this is the project level. We browse the PLC variables and then go to our main role. This is the YT chart. YT chart again. YT chart gives us one entire picture view. And within this picture view, we could have a multiple axis, y-axis, okay? And if you do need multiple Y chart, then under the scope project view, we can right-click, click the new YT chart, okay? For example, this is the YT chart 1. We can call that YT chart 1. And this is the YT chart 2, so we can rename YT chart 2. Okay, so we can switch back and forth. Okay, for example, this chart, you are recording all the variables for the servo motor, and this one you are recording for other tool status. So you could have a multiple charts, and within every chart, you could also have a multiple axis. This is very flexible. Then here, I could have a 2 axis. One axis record the input. Another axis specially record the sine cosine result, right? For this YA and YB. So for this axis, I can rename. This is the axis for X1. X input. Okay? And then for this one, axis group, I can rename. This is the axis for Y output. But temporarily, we don't know for these 2 axes which one is which, right? By default, they are the same. So from the right side, we can see, firstly, let's click this axis X input. And from here, we can select this color. For example, the input we can set as a red. Then we will see, okay, I set this red, then this X input here, that changed to red. Then we know, okay, this axis represent the axis X here. Also, importantly, this title. So we know this red axis represent X input. So I highly recommend you change this name. Use this same name for this title name. Okay. Enter. And then we show the title. Then we know, okay, this axis, that's the input. And this one, this is for output. So for this output one, click, and the right side, this is the Y output, right? Okay, so we will use the same name. Rename, copy for this axis. So we will show for here, this title. Okay, Y axis, and we will also show the axis name. Okay, we see here. And we can also change this color to dark blue, for example. Okay, here, that's very clear. We have a X input and a Y output. We know which one is which. Okay, and also we know the X input, that range always from 0 to 360. So other than this auto growing only, we can define the maximum and the minimum of the range. So we can also hold this range, right? So your grade and this position always floating. Some cases we don't like that because the reference always change. Especially you are going to compare the current one and the old one, right? So now for the scope mode, we can pick to manual way for this x-axis, okay? This x-axis. When we select the manual way, here the manual maximum and the minimum we can change. For this case, I can change to 0 to 360. Or we can change to -5, we leave a little bit buffer, to 365. We can see, we can manually set this range. So that can guarantee this x value always changing within this range. Okay? To compare this performance, I will leave this y, this blue one, as a default. I will leave this scale mode as the auto grown only. So the value of this axis will adapt with the value changing. Some cases, that's the convenient. Okay? Now we can turn on the recording and we can see the actual recording status using this train function. To start up, we can click this start record or click F5. Okay, let's start. Okay, here I have one error. Okay, TwinCAT management features denied, auto restart record. Okay, so because we are using the free license and we are not going to record a long term, we are just to use this management system for short-term troubleshooting. Then this auto restart record, we need to turn this off. Okay, otherwise it need a license. Okay, let's go to the project view, and for this restart recording here, I will turn this off. Okay, sorry about this. For free version, you need to turn this off. Restart record. Okay, and then let's click this start record. Okay, and once we start up, we will see this will turn to this dark blue. Okay, waiting for us to stop. Okay, and in the meantime, for this YT chart, we can switch and we can turn on the individual one. Okay, depends on which one we need to record. So now we are focused on this YT chart 1. YT chart 1 here. We can click this start. Before we start record, now which kind of variable this chart will going to record? We haven't assigned that yet. As I introduced x, we will record the x value. So we will drag this x value under this axis, okay, under this hierarchy. That means this axis will monitor this x1. And for this y-axis, we will monitor the two sign calculated result. We will multiple select them and drag to this y-axis. Okay? So after we dragged it, we can click this start record. Click the start record. We can click this pause or click this start display. And when we pause that, actually behind is still recording. It doesn't matter, it won't lost the data. But if you temporarily want to see the data because it's shifting, right? So you can temporarily pause that. You can monitor the value. And once you put the mouse here and you can click the left button, okay? Then you will see, okay, this curve, that's the YA sign. It shows at the time value it was, okay? And in the meantime, while we are pausing here, the recording system is still working behind, okay? Once you click, it just go. It still record behind, okay? And from here, click this overview, you can see a global picture, how long we record already. And also you can move this cursor and go to that short period. And this is the global view from this 0 second to the recent 1 minute. Okay, because we said 1 minute, right? So this range always show the 1 minute. Okay. And then you can zoom out or zoom in. We can pause that and we can use this button and we can zoom in and we can see at this short period what the value of them. I can click the left mouse, click, and this is YA and this is YB. And this green, that's the X1. Okay? And this point, that's the 348 degree, 351 degree. Okay? And once it's got a 360 degree and burn, it go to 0. So this is the curve, and you can move mouse or you can shift back and forth. You can click this button and shift back and forth. This is very convenient. Okay, and meantime, some cases showing all those values in one chart, it looks a little bit mess. Then you can click this chart 1 and you can select this stack date axis. So once I shift to true, then it will separate. So this is the input, this is the output, right? This is very clear. Some cases, this area can be record all those motors torque value, and this can record all the motors current or speed value. This is the speed value, they are using the same axis. And the torque value, they are using the same axis because they are unit, they are the same, right? But from here, the time axis, they are the same. So you can still watch for all those motors at this short period. If I pause, yeah, short period, so the torque and the current, what the value of them. For troubleshooting case, this stack or not, this is a very frequent function. Or some cases, you may set up multiple axes or multiple value. You can temporarily disable. Disable means it won't record this value anymore. Or, very simple way, you can still enable that, but invisible that. So you temporarily invisible that, but behind it still record that variable. So you can pick this visible or disable. Once you disable, you can see this cross. Okay. Some cases I like to this disable function because for visible or not visible, it's hard to see inside. We will see a small curve difference. If I enable visible, we will see a small curve showing inside. If I click the invisible, we will see this is empty inside. But for the enable, it will show a cross. This is very easy to see. Okay, this curve, I disabled that before. To notice me not forgetting this. Okay, we can see you can create a multiple axes. And the axis, you can also show visible or invisible, or even disable. So once we disable, we only have one axis here. So this whole axis will be disabled. Okay, you can see a cross here. And enable and visible. So we'll see this is very convenient. Okay, and you can also create a different chart. So different chart, you have different applications or different scenarios. So you can record all of them. Okay, and you can use this to move back and forth and zoom in, zoom out. Okay, or select a global picture. For here, you can pick the time, and you can move forward, scroll left, and scroll right. Okay, and then I can click this stop recording. Stop recording here, stop recording. You can click yes to save the data. And after we stop this recording system, we can click this save data. Okay, we can manually make sure we save this recorded data. So it will ask me, do you want to append the scope data? Okay, if we select no, we will choose the directory. If we select yes, then it will save this recorded data to this default directory. Okay, now if I select no, after I select no, we can save this record data to somewhere else. If I select yes, then it will save this YT scope project, the data with this name. Okay, so color has been changed, update color. Okay, then we can go to the directory. So this is my project directory, and I can go to this measurement project. Okay, this appendix SVDX, this is the record data we did. And you can also open this record data. Okay, now we can see. Okay, actually it's opened already. If I delete this, we click this remove from this project. Okay, if I click the remove, this file won't be deleted. It just remove from this project. If we are going to open this record data curve, then we can click here, this measurement project, this hierarchy, click add this existing item. Then we can open the existing item, okay, this one, SVDX. So see this icon difference, this small database showing here. If we open, Okay, click yes. So we can see a named YT scope project. We can see this icon. This icon means we stored this data. This comes from stored. Okay, we have this Y1. It's a curve showing here. If you double click this variables, it will highlight. Okay, it will highlight. Notice you, especially when we select this non-stack view, for example, we select this non-stack view, there will be a bunch of curve showing in one picture. Then if we double click, it will highlight. Okay, notice us. Okay, this is the curve we are looking for. And also from this offline, we can also change the color. So for example, we can change the color to this. Okay, we can change to another color, right? Okay, I will change back to red. Okay, use the new color. Okay, this is the X. Another feature I like to introduce, that's the marker. For example, especially for the offline review, some cases we do need a line showing here, so we can drag the line. We know at this moment what the value of them, right? So for this case, I can right click, add this new Y marker. Look at this symbol here. This is this style. This is the horizontal, and this is the vertical. I will select one horizontal and one vertical. Okay, vertical one and the horizontal one. Okay, they have a different color here. So as we can see, this time marker, this dark yellow one is here. I can drag this time marker to the place I like to drag. So this marker point to the time. So I right side here, make sure we select this time marker. Okay, I right side here. Default, that's only show the position it locate within this chart. But personally, I like to select this band value, select true. Then, because we are pointing to the x-axis, that is the time. So once we select, it is showing the time where we are. So if I drag this time marker, we will see the time is changing here. Okay. So it notice us at this moment what the time it was. And this horizontal one, we select this marker. Okay. We can also drag up and down. Again, so this drag up and down, we can select this marker, make sure select this marker, right side. We can also bind the axis. Okay, bind the axis. Okay, because we are under this axis here. So a band with this axis, this is the Y value. Okay, so this marker, we select this band axis, and this is the position value. So if I drag this value to 3, here 3, and we will see marker, so almost at 3, right? And we can change to different color. So we can create multiple marker, especially when we compare the time from here to here, right? Some cases we want to compare the period within this 3 seconds, what the value they were, right? So we can create a 2 time marker here, and you can calculate, compare something, or you can zoom in, compare some detail at that short period. So at that short period, so what the 3 values they were, right? So using the time marker, it is also very convenient. Again, we are at this offline. So actually from this online, you can also create this Y marker and the time marker. For example, now I can click this. So I can drag this time marker to some place, right? And I can also start over again. Now save, let's start recording this value. Okay. So we can also use the time marker at this online, this scope project, and this icon shows is recording. Okay, we can click this stop record, stop record. Okay, we stop this record, and then we can save this record data we just saved. Okay, do we want to append? Let's click yes. Okay, it saved this record data. So we will see it automatically adds this _1. So it won't override the record data we did before. Okay. And if we go to the folder, we will see we have a 2 record data here. Look at this icon here. So this is the second one. Okay, we can also click this, remove. Now, for this _1, I can click this delete. We will see this file will be deleted. Okay, so I click this delete. Okay, I delete. Okay, we only have this online project here. Now I go to the folder, we will see that _1 was deleted. And now I can rename this database. So it's easy for you to review in future or do some report, right? So for example, I rename this timestamp as June 30. Okay, it's June 30. And then you can copy this file. And once you are going to use this record data, you can click here, click add, and click this existing icon. You can add that back to this project. Okay, you can add that here. Then you can review. This is super convenient. All right, these are the features of this measurement function. I just briefly introduced some key features I usually use for daily engineering job. Again, this measurement project system is not only for the TwinCAT PLC. If we click this target browser, so from here, we can actually use the OPC UE to browse other PLC's variables. And we can drag all those variables back to this measurement project and we can monitor. And this software is for free for short-term use. So it's very convenient to monitor something. It's kind of like an oscilloscope function. Using the function is very convenient to monitor and troubleshoot the signals and variables in a short period, even in a couple milliseconds, that short period. Okay, this is the topic for today, the TwinCAT measurement system to show the scope or the curve function. Thank you for watching. Thank you for watching. If you like this video, please give me a thumb up. If you like to watch more videos in my channel, please subscribe and hit the bell. Thank you for watching.